Alright, so in this video, we'll be discussing February-March 2024 Pure Mathematics 3, Paper 3-2. Question number 1. They want us to find the quotient and also the remainder when this quadratic equation is divided by x squared plus y. Okay, so to find the quotient and also remainder, basically for me, I'm going to use the long division. Okay, so for the long division here, I will just copy down my polynomial to be divided. So 4 x power 4 minus 3x cubed plus 9x squared minus 12x, then plus 27. Okay, and then for my divisor here will be x squared plus 5. And then to avoid any confusion or careless mistake, what I'm going to do is like x squared, then I'm having nothing, no term with power x power 1, right? So I will write it as 0x power 1, then plus 5. Okay, so first of all, we are looking at the first term and also the first term for the division. So something multiply with x squared to get x power 4. So what is the something here? So the something here should be x squared. X squared multiply with x squared, you're having x power 4. X squared multiply with 0, x, you're having plus 0, x power 3. Then x squared multiply with 5, you're having 5x squared. So this is basically how we carry out the long division. And after you decide the first quotient here, then you need to minus, all right, the term on top by bottom, minus the top from the bottom from the top. So x power 4 minus x power 4, you get 0. X power 4 minus x power 4, you get 0. Then for this one, negative 3x cubed minus 0x cubed, we are having negative 3x cubed. 9 minus 5, you are having 4. Okay, so I bring down the negative 12 here, 12x. Alright, so again, let us focus on the first term one more time. So I'm having currently negative 3x cubed and also x squared. Something multiply with x squared to get the 3x cubed. So what is the something here? The something here should be negative 3x. So negative 3x multiplied with x squared, I get negative 3x cubed. Then 0x squared. Then 5 times 3 is negative 15, right? So negative 15x. Then I draw a line again. Then I minus the top and the top bottom. So negative 3x cubed minus negative 3x cubed, I got 0. Okay, second term here, 4x squared minus 0x squared, I'm having 4x squared. Negative 12 minus negative 15, I'm having positive 3. Then again, I pull down the remaining term, which is 27. Then again, focus on the first term, 4x squared and also the x squared. Something multiply with x squared to get a 4x squared. So the something there should be a 4. Okay, so 4x squared multiply 4 multiply with x squared, I'm having 4x squared. 4 multiply with 0, I'm having 0x. Then 4 times 5, I get a 20. Okay, so there's no more term that I can pull down anymore. So what am I going to do is I'm going to calculate the remainder. Alright, so 4x squared minus 4x squared, I got 0. Then 3 minus 0, I'm having 3. Then 27 minus 20, I'm having a 7. Okay, so from here we should know that quotient means the top part we call as quotient. Okay, and then this bottom part here we call as remainder. So this question is asking us to find the quotient and remainder, right? So usually for my own practice, I prefer to rewrite my answer again clearly, where the quotient should be equals to x squared minus 3x plus 4 and my remainder equals to 3x plus 7. Alright, so this is how we solve question. Alright, so question number 2. Find the coefficient of x squared for this particular expansion. Alright, so to expand these two product, 2x minus 5, this bracket is power 1, so I cannot expand anything. But 4 minus x, I'm having power half. So basically, I can use the binomial expansion formula to expand the bracket of 4 minus x power half. Alright, so just in case if you forget the formula for binomial expansion, you can have a look from the table, MF19 from booklet. Then please scroll down to the part binomial series. So we are having two formula here. So the top one actually is the AS syllabus one. So for ours one will be the A2 syllabus, which is this one. Okay, so I'm trying to copy it here to the page, to our question page, so that you can refer to it. Okay, so let's adjust it here first. Okay, so this is the formula that we have here. All right, so let's have a look. Okay, so for your information, right, if you have to look for this particular formula, you have to make sure that to apply this formula, the coefficient start from 1. The first term in the bracket start from 1. But in our solution here, okay, our question here, we are having the number which is not started from 1, which is a 4. So we have to do a little bit of adjustment before we can apply this particular formula. Alright, so to adjust it, I just copy the 2x minus 5, the first bracket, since we cannot do anything. I want to take out the 4 from my bracket. So take out the 4 from my bracket, I have to include the power together with the 4. So which is become 4 power half. After I take out the 4, it will become the 1. So after I take out the 4 from the x, I should have x over 4. So you try to imagine, if you have x over 4 here, multiply with the 4 later, you will get back to x. Okay, you get back to x like what they show here. Okay, then don't forget about the power half for this particular bracket. Okay, so what is the square root of 4? Square root of 4, you get a 2, right? So I'll put the 2 in front since we are not going to expand it also. So I'm having 2x minus 5, then 1 minus x over 4 power half. Okay, so if I try to observe this bracket now, it is the same like what we have here, right? So the first term start from 1. Okay, so for this particular bracket, the x is now become negative x over 4. And then what's the end here? The end here will be the half in our question. All right, so I'm going to substitute all the relevant value into the formula. Okay, so the first term is a 1, so I just copy a 1. Second term is n times x, so the n in this case is half. The x in this case is negative x over 4. Then n minus 1 and also divided by 2 factorial. So when I'm having here, I'm having n, which is a half, n minus 1, which is negative half, divided by 2 factorial, then multiply with x squared. So again, my x now is negative x over 4 and I square it. Alright, and I will stop at this particular term here. It is because of, in our question, they requested for the coefficient of x power 2. So we are interested until this particular term, which is the x power 2. So for x power 3 later, we actually don't need it anymore because they are not concerned about that. They only want us to focus on the coefficient of x squared. Okay, so again, continue to expand and simplify slowly. For this particular bracket in the binomial expansion, if you press calculator and simplify slowly, you should have 1 minus 1 over 8x and also negative 1 over 128x squared. Alright, then further expand it. So expand now, I try to expand these two brackets, this bracket and also this bracket. First term multiply with first term multiply with second term, first term multiply with third term, and so on. Alright, so if I try to expand them, by right, you have all the terms with constant, then x power 1 and also x power 2. Since for this question, they're interested for the coefficient of x squared only, so I will just focus on the x squared term. So like for this one, 2x, right? How can I get an x squared? So 2x, I have to multiply it with negative 1 over 8x. So when I'm having 2x, multiply with negative 1 over 8x, I will be having 1 over 4 negative than x squared. Okay, settle for this first term. And how about the second term here, the 5? So 5, how can I get something with x squared? So for this 5, I have to multiply it with this one, the term with the x squared, to get the term with x squared. Right, so negative 5 multiply with negative 1 over 128, I'm having positive 5 over 128 x squared. So from here, you can see that my step is shorter because I only focus on the term that we are interested, which is the x squared. Then simplify these two terms and also multiply the 2 together with it. You should be having negative 27 over 64 x squared. And since they're asking for the coefficient of x squared, right? So I should try to write out clearly the coefficient of x squared should be the number in front of the x squared only, which is negative 27 over 64. Okay, so this is how we solve question 2a. And let's continue to part number B. For part number B, they're asking the value, the set of values of x are when the expansion is valid. Okay, so if we have a look for the formula again, all right, so this is the formula that we apply here, right? Then they say where n is rational and also modulus x smaller than 1. So that means on this formula is true when the modulus x is smaller than 1. So how I actually get this particular term here, modulus x smaller than 1, comes from the bracket itself. So they are taking the variable at the back, modulus, then smaller than the number in front. Okay, so same thing happened for my expansion here. So this is particularly my expansion, right? 1 minus x over 4. So by right, when I want to write out the valid value of x should be modulus x over 4, then smaller than 1. Okay, so I'm going to apply this in our part B now. Okay, so by right, we should be having modulus x over 4 smaller than 1. Since 4 is a positive value, right? So it is okay that we take out the 4 and multiply it to the right-hand side. Okay, you can write out in this way, or you can expand it by using the modulus formula, where the x should be between -4 until +4. Like the line is not straight. Okay, so this is how we get the answer for the part B lah. Alright, so just make sure that you always remember the method how to get or how to write out the set value for x where the expansion for binomial is valid. Okay, so this is how we answer question. Okay, so question number 3, we are given the complex number z. Okay, then they want us to express z squared in this exponential form, where r is greater than 0 and also the data should be from -pi to +pi inclusive. Okay, so to find out the z square or z power 2 in the exponential form, basically there are more than one method that we can get the answer. Alright, so from here I'm going to show you method number 1. Okay, so for method number 1, what am I doing here is I try to use the idea where we should know that the modulus of z squared, right, should be equals to the modulus of z and then we square it. Okay, this is something that we should know about it. There are some simple property or formula that we can apply. Then if I want to find the argument of z squared, argument of z squared means that it is argument of z multiplied with z, and basically we can write it out by using argument z plus argument z. Okay, then you need to do some adjustment if let's say the range of data is already out of -pi and +pi. Then you have to do a little bit of adjustment here. If let's say your value here is out of the range. Okay, alright, so this is the method number 1 that I'm going to use. Okay, alright, so first of all, I try to find out the modulus of z first. So what's the modulus of z? It will be equals to a squared plus b squared square root, right? So my a is -√3 then square plus b squared is 1 square. Then you're having a square root 4. Then from here, you know that your z is equals to 2. Modulus z equals to 2. The length, all right, for this particular complex number is a 2. And how can I get the argument of z? So the argument of z, basically, -3, negative square root 3 plus 1. Negative square root 3 plus 1 is actually in the second quadrant, right? Okay, this is negative square root 3, and this is the 1. So this particular complex number should be in the second quadrant. So to get the angle in the second quadrant, I have to take 180 minus this area in the this angle in the triangle. So I'm going to take 180, which is a pi, then minus the angle in the triangle. It should be tangent inverse 1 over square root 3. Because if you know this is a 1, then the bottom part here is a square root 3, right? So it should be tangent inverse 1 over square root 3. Then by using a little bit help from calculator, you should be able to get pi minus pi over 6. And you get 5 pi over 6. Alright, so this is how we actually find out the modulus for z and also the argument of z. Okay, then now, let's proceed further. Since they want us to find out the x squared in this exponential form, right? So for the exponential form here, if you try to observe, the r here is the modulus of z squared. Okay, and the theta here will be actually the argument of z squared. Okay, so if I'm able to find the argument of z squared and also the modulus of z squared, then I can rephrase the z squared in the exponential form. Okay, so let's continue. Now I want to find out the modulus of z squared. So like what I told you just now, modulus of z squared can be written as modulus of z and then you square it. What's the modulus of z that we get just now, which is a 2, right? So you get a 2, and then now I have to square it. Therefore, the modulus of z squared is a 4. How about the argument of z squared? So like what I told you just now also, if you have argument of z squared, it means that it is argument of z plus the argument of z. So I'm having 5 pi over 6 plus 5 pi over 6, which is the argument of z. So when you add these two arguments together, right, you realize that the answer is already bigger than pi. It is already out of the range because our theta should be from negative pi to positive pi. And you realize that, oh, this is already out of the range. What can we do here is we have to minus 2 pi. That means we have to adjust it to the angle earlier, one round earlier, so that it become back to the range, all right? So I take 5 pi over 6 plus 5 pi over 6, then minus 2 pi here, I will have negative pi over 3. Okay, so from here, you're able to see that I got 5 pi over 6. I got the modulus. Modulus is 4. And also, I get the argument, which is negative pi over 3. So from here, it should be no problem for us to write out the z square in exponential form. Sorry, I have to move it a little bit up. Okay, so from here, my answer for the z square in the exponential form will be r. R is 4. Okay, so e power theta I. So my theta is negative pi over 3 and then I. This is how I express the z square, all right, in the form of exponential form. So this is one method where I try to use the formula here, the property of formula, to get the exponential form. So this one, it involve the modulus and also the argument for z only instead of z squared. Okay, all right, so this is method number 1. And then we have another option for method number 2. So if let's say you don't really remember or don't really know how to apply this particular type of formula, then you can consider a second method. Second method basically is you try to find out z squared first, and after that you try to find out the modulus and argument. That's it. Okay? Right, so let's start with method number 2. So z squared, what does it mean by z squared? It is negative square root 3 plus I multiply with negative square root 3 plus I. Okay, so if you try to expand it, you will be having 3 minus 2 square root 3 I, then minus 1, right? I squared is a negative 1, so minus 1. From here, you are having 2 minus 2 square root 3i. Okay, then since I already know what is my z square, so to write out in the exponential form, I need to find out the modulus first. So the modulus of z square will be 2 square plus negative 2 square root 3 squared. Okay, so you'll be having 16, square root 16, and therefore the modulus of z square is a 4. You can try to compare it with the method that we used just now. We are getting actually the same length, right? The same modulus. Okay. Then how about to find out the argument? Okay, so again, to find the argument of z square, you get this one as a z square, which is 2 minus 2 square root 3. So 2 minus 2 square root 3 basically belongs to the fourth quadrant. So this is 2. This is 2 square root 3. Okay, so to find the angle, it is measured in this direction, in the negative direction. So for this negative direction angle, right, to find the angle here, it is actually negative basic angle. So I just put negative tangent inverse the basic angle shouldn't include the negative sign in the calculation. So I didn't put any negative with me here for the tangent inverse. Then this tangent inverse 2 square root 3 over 2 basically is the basic angle. Alright, so again, if you press a little bit of calculator and solve it, by right you should have negative pi over 3. Then again, from here, you'll be able to rewrite your z square into the pattern of exponential again. So r is a 4, then e power negative theta I. So theta is negative by 3, pi over 3, then I. Okay, and this is the way lah. The second method that we can use here to find out the z square in the exponential form. Alright, so you can try to compare these two and see which one you understand better, then you can apply any of them in the exam. Right. Okay, then let's continue to part B. So for part B, they are telling us that this complex number here, okay, they want to find this W complex number. It looks like W, right? Okay, so z square multiplied with W is real. And then z square divided by W, the modulus is a 12. So these are the two information that I can get from the question. Okay, so what should we do next? They want us to find the two possible values of W, giving your answer in the form of this one, R e power I alpha. Okay, then again, where R greater than 0 and also alpha between negative pi until positive pi. Okay, then again, they want us to express our answer, final answer in the form of exponential form. So again, because for this question, we actually don't know what is our complex number here, the W, right? So you can't apply this particular method that I showed you just now, right? This one. Because for this one, you know both Z and Z, they are the same. Then you can expand, get the answer, then only you find the modulus. But for this question, because there's an unknown for the complex number, unknown complex number, so you cannot apply the method that we used just now. So we go back to, we have to use this particular method here, method number 1. So just to recall back, modulus Z is a 2, argument Z is 5 pi over 6, okay? Alright, so let us continue from here. Okay, so maybe for me, I want to start with the modulus of Z square over W. So they told me that the modulus of Z square over W is equals to 12. But for your information, we can separate this modulus by using modulus X square divided by modulus W. And it is equals to 12. Basically, what is the modulus of Z square? So modulus of Z square just now, you get a 4. Okay, so you're having 4 divided by the modulus of W equals to 12. And now from here, you successfully get the modulus of W, it will be equals to 1 over 3. Okay, so since I already know that the modulus of W equals to 1 over 3, then let's continue further to get the data or the argument of the W. Okay, because we need both argument and also the modulus to write out in the exponential form, right? Okay, so how can I find out the angle alpha? So I'm going to use this one. Z square, they told us that Z square W multiplied with W is real. Okay, when we are having a real number, means that my complex number should be lying on the x-axis, either this one or either the blue color one. So this one means that the Z square W is real. Okay, so it's real means that you're having 0i. So if you're having 0i, means that you should have the complex number that lies on the x-axis, either the green color part or the blue color part. Okay, so now let us start the first one. If I have the green color part, let us talk about the green color part, So if let's say I'm having any number on the x-axis part, what do I have is we are having maybe x and 0. So x plus 0i. Therefore, it is real. So when you're having, I'm talking about this green color now, So I can write out the argument of Z square W. Let's say this is my green color complex number. I know that they are real. Therefore, the angle should be 0. Okay? Then just now we have learned argument of Z square plus the argument of W can be equal to 0. So what is that? I got my argument of z squared. So argument of z squared, just now you get the value, which is negative pi over 3. So I'm having negative pi over 3. Argument of w, I don't know. So I'm having 0. From here, I get your argument w equals to pi over 3 positive. So this is the first argument that I have, which is in the green color. Then, if let's say this complex number is real, right, I have another option where it lies on the negative x-axis. At the negative x-axis also, you won't see any complex number I, right? Because it is something plus 0i. The y-coordinate is always 0, so it should be something plus 0i. Okay, so for the blue color part, what am I going to do is, I will have argument z squared w equals to what? You measure it from positive x-axis until here, it should be 180 degree, which is equals to pi. Okay, then again, using the same method here, so I'm having argument of z squared plus the argument of w equals to pi. So negative pi over 3 plus argument of w, okay, equals to, what is the value of pi here? It is still pi. Okay, then very easily you can get another value for the argument of w. So you take pi plus pi over 3. So from here you have 4 pi over 3. Then again, if you have a look for the 4 pi over 3, right, you realize that it is already more than outside the range, because here they are telling you that alpha should be between negative pi to positive pi. Okay, then my alpha here, the argument for w here already more than the positive pi. So I have to minus 2 pi to adjust it back. Okay, to find out the angle in the previous one round. Okay, so from here, I get my argument of w equals to, what should it be? It should be 2 pi over 3. Oh, sorry, negative 2 pi over 3. Because this one minus 2 should be negative 2 pi over 3. Okay, so here I got two arguments for the w and also one complex number, one modulus for the w. Therefore, I can write out the w into the exponential form, where the w can be the modulus, which is 1 over 3 e power theta I, or e power alpha I. So the first alpha that I get is pi over 3. So I'm having pi over 3i. Okay, and we have the second answer where my argument is negative 2 pi over 3. So again, w can be written equals to r, which is a modulus, e power the angle. So the angle is negative 2 pi over 3 and I. Okay, so this is the method we use to find out the modulus and also the argument for w, and hence we can rewrite it again into the exponential form. Alright, yeah, so this is how we solve question number 3. Okay, so question number 4. The positive number p and q. So remember, the p and q value are positive values, yeah? Okay, such that ln p over q equals to a, ln q squared p equals to b. They want us to find out ln p power 7q in terms of a and also b. Okay, so first of all, we should start from the information, the equation given by the question first. I start from this part. So for this particular part, right, if I use the property for ln number, I should get ln p minus ln q equals to a. Agree? So this will be my first equation. And now, second equation I'm having, I will use this to start. So ln q square p equals to b. So again, the property of the ln number, it should be 2 ln q plus ln p equals to b. And this is my second equation. Alright, so I plan to find out the ln p and ln q first, and after that I can substitute into this expression here. Okay, so since I have two equations here, right, I can solve them simultaneously. Okay, what am I going to do now is I take equation number 2 minus equation number 1. So 2 ln q minus negative ln q, I will have 3 ln q. equals to b minus a. So b minus a. And I get my equation where ln q should be equals to 1 over 3 b minus a. Okay, so this is my ln q lah. But of course, I need to find out ln p. So for ln p, maybe I substitute into the first equation here. Alright, so I'm having ln p equals to a plus ln q. A plus, this is the ln q that I get here. So 1 over 3b minus a. Right, then if I further simplify it, then I'm having 2 over 3a, then plus 1 over 3b. So this is my ln p here. Okay, so these two equation is important because I'm going to substitute them into my expression later to get the final answer in terms of b and also a. So now they want us to find out ln p power 7q. Okay, so what do I get? Ln p power 7q. You can expand it again by using the log property. So I'm having 7 ln p plus ln q. Then you should know what to do, right? Substitute ln p into this expression and also ln q into this expression. Then you can see that your final answer basically is in terms of a and also b. So this is my ln p. Then what is my ln q here? It will be 1 over 3b minus 1 over 3a. This is my ln q. You can get it from top lah, right? Then further simplify everything. Okay, so if you try to simplify everything, by right, you will be having 13 over 3 and also 8 over 3b. 13 over 3a, 8 over 3b. So I can factorize out the 1 over 3. Then I'm having 13a plus 8b here. Okay, so this is how we solve this question number 4. Question number 5. We have, they want us to sketch on an Argand diagram for these two inequality and also shade the region. Okay, so let's have a look for the first inequality first. Okay, for this particular first inequality, I need to change it, become the pattern of modulus z minus a complex number smaller equals to 3. So how can I put this into this pattern? So by right, you take out the negative from the 4 and also 2. So you'll be having 4 plus 2i. Okay, so when you're having one side with modulus and also the z, z minus a complex number equals to or smaller to or greater to than the number on the right. Basically, this is a circle where the 4, 2 is the center of the circle and the value here will be the radius. Okay, all right. Then how about for the second inequality? Modulus z greater equals to 10 minus z. So modulus z again, I want to write it become z minus some complex number greater equals to, what can we do is like, you can make it become z, a complex number minus the z. Okay, so for this complex number, it should be 0 plus 0i on the left-hand side. For the right-hand side, it should be 10 plus 0i. Okay, all right, so when you're having both sides with the complex number, right? Both sides with the modulus function, right? Modulus sign. Basically, it is the perpendicular bisector for these two complex number points. Okay, so some students might ask, if I have because last time previously when we try everything, right, we are having the positive z, then minus a complex number. Then how can we draw a complex number minus the z? Basically, they are the same. Okay, so both of them are having the same meaning, where the distance between the complex number z and also the complex number 10, 0, this is the meaning of the sign modulus. Modulus means the distance between these 2 points, the z and also 10, 0. So if you write in this way, also the same meaning, where they are bringing the meaning that the complex number z and also the point, okay, tan 0. Modulus means the distance. So in short, it means distance. Modulus means distance. So distance between z and tan 0. This also have the meaning with distance between the complex number z and also the tan 0. So they are basically having the same meaning, right? Okay, so we are having this as a perpendicular bisector lah. So later we will decide which is the area that we are interested to shade. So first of all, let's start with this one first. I'm having 4 and -2 as the center, and then the radius is a 3. So if you want it to be accurate, then maybe you can try to label it as accurate as possible if you can. Me personally, I try to use the ruler and maybe measure the ratio, the scale. Okay, so this is what I have. So first of all, I want to draw the circle first. The center is 4, 2. So 4 is here, 2 is here. This is the center. And then they say the radius is a 3, right? So I try to use the ruler and try to plot. There are a few points that's 3 units away from the center. So the top one, you become a 5, right? Then the bottom one, you become -1. So if I plot it, it will be something like this. Then I try to connect them, all the points here, by using a curve, and then I try to draw it as circle as possible. Alright, so this is my circle. Alright, although it doesn't really look like a circle, but assume that it is a circle. Okay, right. Then they are saying that z minus 4 plus 2i, right, smaller equals to 3. That means you're interested for the area where the radius of the circle is smaller equals to 3, the complex number, okay? The distance between the complex number and also the center is less than 3. So by right, you should shade the whole area inside the circle. Okay, all right. But at the same time, you also need to consider the second locus here, z minus 0 plus 0i. So 0 plus 0i means this point. Then 10 plus 0i means here. So you have 8, you have 9, and also 10. Okay? And then the distance, the perpendicular bisector between 0, 0 and 10, 0. Where's the perpendicular bisector in between? So it should be this one. Okay, so we should be having the vertical line where x is equals to 5. Okay, because it is actually the perpendicular bisector between 0, 0 and 10, 0. Okay, this is 90 degrees between the 0, 0 and 10, 0. And from this inequality, you can see that z to 0, 0 should be more than z to 10, 0. So that z to 0, 0 should be more than z to 10, 0. It means that z should be somewhere closer to 0, so that the distance can be z to 0, 0 is more than z to 10. Correct or not? So z should be somewhere here. And according to what we have just now, since we are talking about the area inside the circle, so overlapping of these two areas, we are having this as the shaded region for this question number 5a. Okay, all right. Yeah, so basically, this is the Argand diagram that we have, and how are we going to shade out the region that the question wants. Okay, then let's continue to part B. For part B, find the greatest value of argument z for the points in this region. Okay, greatest value for argument z. Argument z means the angle. So I have to get the largest argument z, the angle of z, from 0 plus 0i. Okay, then again, I need to use my diagram, okay, to answer this question. So let's have a look for the diagram again. So for convenience, I will want to copy it down, then I paste it on this file. Okay, a moment, yeah. Okay, so let's say this is the diagram that I have. I can directly refer here and solve it. Okay, then let's have a look for this one. Okay, they are asking for the greatest argument z. So the argument z, basically we are going to measure it start from 0, 0 because z minus 0 plus 0 I ma. So I have to measure it from 0, 0. On the right side, right hand side of 0, 0, I draw a line, a horizontal line. Okay, and where is the complex number z so that I can get the largest angle. So as example, if my z is here, let's say this is the z. If I draw a line from 0, 0 to the z, right? So this is the angle. Where should I draw my z so that the angle will become as large as possible? So you should push up the z, right? When you push up the z until the edge of the shaded area, then I think this point will give you the largest value of the theta. So your largest value of theta basically is this whole thing. Okay, all right, so now we need to think a way how to find out this theta here. How to find out this theta here. Okay, so we might need to use some knowledge in maybe coordinate geometry or maybe some triangle property to find out the answer. All right. So it depends. There's no fixed method. So basically, it depends on your knowledge, okay, or your idea of using all the concepts that you learned before to solve this question. Okay. So for me, right, because I know that this is a circle with the center 4, 2, and also the radius 3. So what am I thinking is I try to form the equation of circle first. So the equation of circle, we learned this in AS before, right? X minus the x coordinate of the center, then y minus the y coordinate of the center equals to radius squared. Okay, so this is a circle equation. And then if I have a look for this point z, right, I know that the point z is having the x coordinate which is equals to 5. Okay, so when x is equals to 5, what happened to your circle equation? So your circle equation will become 1. Okay, then if you try to solve for the y, you will be having plus minus square root 8. Okay, then plus 2. You're having two values of y. The first one is this one, which is y equals to 2 plus square root 8. It should be a large value, right? Then another y will be somewhere here, because when you solve for x equals to 5, you get two value of y, which is correct because you should be having two distance 2 point, okay, of intersection between the line x equals to 5 and also the circle. So for this particular value of y, it should be y equals to 2 minus square root 8. Okay, then now again we come back to our main point here. Now I want to find out the angle theta, right? So to find the angle theta, basically if I have some the length, right, for the height and also the base for this particular triangle, then I can find the theta. So maybe I put a highlighter here. So can you see this triangle here? So for this triangle, now I already know that the height for this triangle is 2 plus square root 8. Agree? Because the z is having y equals to 2 plus square root 8. So from x-axis until this particular height, the height is 2 plus square root 8. Then how about the bottom here? So for this bottom here, the base of the triangle is actually a 5. So to find the theta, you can use the tangent triangle to find the theta, right? So where we are having the tangent theta can be written as 2 plus square root 8 divided by 5. Therefore, to find the theta, it should be tangent inverse 2 plus square root 8 divided by 5. So from here, you successfully find out the greatest argument for the z. So which is the theta lah. So you can rewrite again. The argument of z that we are going to get is, press calculator to help you. Okay, you will get either a 44 degree or you can put it in a range, in the radius form. So if you use radian form, it should be 0.768 radian. Okay, so this is basically what we have lah for the greatest argument of z. I believe that this is not the only method that you can get an answer. Yeah, you might have some other possible method that is logic and valid one. You can just use it. All right, so this is just a suggestion where I'm trying to find out the equation of the circle, and after that I try to get the length, the height of the triangle, and also the base of the triangle lah, to get the greatest argument for the z in this question. All right, yeah. So this is how we solve question. Okay, so question number 6. We are given the equation like this. They want us to show that dy dx can be expressed as a fraction like this. Okay, so we'll directly start from the equation given. So this is an implicit equation, implicit function. Therefore, we cannot separate clearly the x and y to two different sides. So what am I going to do is now I have to use the implicit differentiation. So you just differentiate like normal, just that when you involve any variable for y, right? So you just need to write a dy dx at the back. So as an example, for the first term, I'm having 2y squared. If I differentiate 2y squared, I will have having 4y. That means you put the power 2 in front, then power minus 1, just like how we differentiate something with the x. But this is related to y, right? So at the end of the term, you have to put it as dy dx. That means we are differentiating the y with respect to x. Plus, the second term here, we are having 3xy. We will treat it as the product of two functions. So maybe the first bracket is 3x, the second bracket is a y. So we have to apply product rule for this question. Okay, so first of all, we differentiate the first bracket. Differentiate the first bracket, you have a 3. 3x become a 3, right? So you copy the second bracket y. Then now you copy the first bracket 3x, you differentiate the second bracket. Differentiate the y, you have a 1. Because of we are differentiating the y with respect to x, therefore you have to put dy over dx. Okay, then same thing happen for the x here. Differentiate x, you get 1. So equals to differentiate x squared, you are having 2x. Okay, so next step, try to factorize out the term that involve the dy dx. And after that, I try to bring the other thing over, become minus. So I'm having minus 3y here and minus 1 here. Then very easily, if you rephrase everything here, you can see that we successfully get the term for the dy dx, as shown in the question, right? Okay. Yeah, so this is what we have for dy dx for question number 6a. Then let's continue to 6 part B. Okay, so for 6 part B, they want us to show that the curve does not have a tangent that is parallel to the x-axis. Okay, so first of all, let's talk about parallel to the x-axis first. What's the meaning for parallel to the x-axis? That means you're having the equation of tangent that is horizontal line. So for horizontal line, right, your gradient should be equals to 0. Okay, when they are saying that the equation of tangent parallel to the x-axis means that dy dx equals to 0. Okay, yeah, so first, I want to let dy dx equals to 0 here. When I let dy dx equals to 0, I try to solve for the equation. If I successfully get the point x that can make us have the dy dx equals to 0, that means the curve has a point, okay, with the tangent parallel to the x-axis. If let's say I'm not able to get the value of of x after I substitute the dy dx equals to 0 into my solution, then basically it means that there's no point, okay, on the curve that actually have the tangent that parallel to the x-axis. So I hope that you have this idea, okay? So I will start with dy dx equals to 0. Okay, so the bottom part here cannot be equals to 0, right? This is my dy dx. For y plus 3x cannot be equals to 0. So what I do is like I directly write it as 2x minus 3y minus 1 equals to 0. From here, I will be having 3y equals to 2x minus 1. Then y equals to 1 over 3, 2x minus 1. Okay, so getting this equation, what I want to do next is I want to substitute this equation into my original equation. Then I want to see whether do I have any solution for the intersection of these 2 points or not, these 2 lines or not. Original equation. Okay, so if I substitute, I'm having 2, then y squared. This is the y, and then I square it. Then 3xy plus x equals to x squared. Okay, so by trying a little bit of expansion and also simplification, okay, so hopefully you will successfully get this particular quadratic equation. Okay, if you can get the value of x from this particular quadratic equation, that means this value of x is having the gradient of tangent or the line of the tangent which is parallel to the x-axis. But now we hope that we won't get any value of x because they want us to show that the curve does not have any tangent parallel to the x-axis, but does not have, right? If you can solve for the x, that means have. If you cannot get the value for x, that means don't have. Okay, so to make sure that I don't get any complex number of x, you can try to solve. You realize you cannot solve. Either you try to use quadratic formula to solve it, then you show that there's math error or no solution. If not, then you can use b squared minus 4ac to prove. So negative 8 squared minus 4ac. Okay, so from here, you get negative 72, which is a negative value. So when you are having b squared minus 4ac smaller than 0, what does it mean? It means that there's no solution for this particular quadratic equation, right? Okay, which also successfully proved that the curve does not have the tangent parallel to the x-axis. The curve does not have a tangent Alright, so basically I'm using the discriminant method, alright, to prove that the curve doesn't have any solution. And if we extend our conclusion, it should be the curve does not have any tangent that's parallel to the x-axis. Yeah, so this is how we solve question number 6. Right, so we are now at question number 7. We are given a diagram like this, and then it actually shows us the curve. So the equation of the curve is this one, and the minimum point is the m at the value of x equals to alpha. So for this question, they want us to show that alpha satisfies this particular equation here. Okay, so since alpha is related to the x coordinate for the minimum point, therefore to try to get the alpha, we try to solve for the minimum point, okay? We try to look at the minimum point. So this is my original equation that I have. To get a minimum point, we need to apply differentiation. So we need to find out dy dx first. Okay, so for the first term here, you can see that it is a multiplication of x with e power 2x. So it is a multiplication of two functions. Therefore, for differentiation, you have to apply product rule. Okay, so I make x as the first bracket, e power 2x as the second bracket. So now we copy the first bracket, differentiate the second. So when you differentiate the second, you have back the e power 2x. Multiply with the differentiation of the power, you get a 2. So this is the step where I copy the first bracket, differentiate the second, and now I need to differentiate the first bracket, become a 1, copy the second bracket, which is still e power 2x. After that, negative 5x, if I differentiate it, I will have negative 5. Okay, so simplify my answer. Alright, so at minimum point, we know that dy dx is equals to 0. Alright, so minimum point is equals to 0. And if you substitute alpha inside this equation, alright, or if you try to solve this equation, you'll get x equals to alpha. So from this step, you can either change x directly into alpha, or you can change the x become the alpha at the last step, also can. But no matter how, we need to try to rephrase my x equation into this pattern. All right, so since we know that if I substitute alpha or if I solve this equation, I'll get the alpha, right? You can directly put in alpha here first, and then you rephrase it into the pattern, okay, that the question requested or the question show. So rephrase this one into this equation. So how can we do that? You need to try to observe a little bit. I'm having a 5 on top, so maybe it's a positive 5. So maybe what I want to do now is I want to take out the 5 to the other side. And then I try to take out e power 2 alpha. Then I'll be having 2 alpha plus 1. And then e power 2 alpha, it will be equals to 5 over 2 alpha plus 1 or 1 plus 2 alpha. So from here, we can see very clearly that we are actually having the term, okay, inside the ln already, the fraction inside the ln. So that means our direction is correct. Then now, to make the e disappear, we need to take ln for both sides. So I'm having 2 alpha ln e equals to ln, then 5 over 1 plus 2 alpha. All right, you need to know that ln e equals to 1, yeah? Okay, so ln e equals to 1, this is something basic that you need to know. Okay, so I'm having 2 alpha here. So to get the equation of alpha, I bring the 2 over. Therefore, I'm having 1 over 2 ln, then 5 over 1 plus 2 alpha. Right, so basically this is how we show and get the equation in terms of alpha by using the idea of finding out the x-coordinate of the minimum point. Right? Okay, then let's continue to part number B. For part number B, they want us to verify by calculation that the alpha lies between 0.4 and also 0.5. Okay, start from the equation that we get in part A. I'm having alpha equals to 1 over 2 ln, then 5 over 1 plus 2 alpha, right? Okay, so to check whether is the alpha lies between the two values that's given, what am I going to do now is I try to rephrase this equation into a function form where I can write it as alpha minus 1 over 2 ln, then 5 over 1 plus 2 alpha. Okay, of course, if you want to move the alpha to the other side also can, where you're having your f alpha equals to ln, then 5 over 1 plus 2 alpha minus alpha also can. Alright, so there are two options. No matter which direction are you moving your equation, right? The final answer will not be contradict with each other. So they should be the same. Alright. Okay, so let's substitute the 0.4 inside my equation here. So if you try to substitute 0.4 into your function, okay, so by using the help of calculator, right? You should be getting one value here, which is negative 0.111. Okay, then if you substitute 0.5 into the function, so all the alpha becomes 0.5. Okay, again, by using the help of a calculator, right, you should be able to get one positive value, which is 0.0419. Okay, but if we are using the function f alpha in this form, in the green color part here, then by right, your answer for f 0.4 should be having a positive value. Okay, then when you substitute f 0.5, you will be having a negative value. The value itself is the same, just that the sign, the positive and negative sign of this value will be different. All right. Okay, so either you show it in this way or either you show it in this way. So no matter which method or which function are you using, right? Basically, you can see that there's a sign change. That means from negative change to positive or from positive change to negative. All right, so this is actually the main point that we want. We want to get the sign change when you substitute these two values, then make a conclusion here. So sign change can be seen between these two values. And this actually tells us that the alpha lies between these two values. Alright, so in my conclusion here, I want to emphasize the word sign change. and that makes a conclusion that alpha lies between 0.4 and also the value 0.5. Okay, so no matter you are using the red color function or green color function, basically the conclusion will be the same. You can see the sign change between these two answers, right? Okay, so this is how we answer part number B. Let's continue to part C. For part C, they want us to use an iterative formula based on the equation in part A to determine alpha correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So again, I recopy again the answer in part A. So I'm having alpha 1 over 2 ln 5 over 1 plus 2 alpha. Okay, so what is the initial value that I can use to put inside the alpha here? The initial value you can decide on your own. Okay, you can decide on your own. So usually what I suggest is you try to get the value from this part B. Because we know that alpha is between 0.4 and 0.5. So if you substitute any initial value from these two values, okay, then basically your step will be slightly shorter. Alright, if let's say you're putting a value that's very far away from the original root or original answer, then your iterative might be longer. So usually what I suggest is that you just take any value that's nearer or closer to the value that they want us to verify here. Okay, alright, so for me here, I will substitute my initial value as 0.5. Okay, then I need to key in the formula for the right hand side on the calculator, the iterative formula in the calculator. So I'm having this. What will it be? Let us have a look. Okay, so half. Then on top you're having ln. Then bracket 5 fraction 5 over 1 plus 2 alpha, 1 plus 2 alpha. So for the alpha, I'll put it as x. Then close bracket. The bottom part, I should be having a 2. Okay, alright, so we are trying to key in the formula, the iterative formula on the right hand side only. When you try to write alpha equals to something else, right? So you key in the expression on the right. So this is an expression on the right, yeah? And now, when you want to input the first initial value, alpha 1, so the first alpha is equals to 0.5. This is what I decide from part B. Okay, then what I press is I press CALC, calculate in my calculator. Then I key in 0.5. Then press equal sign. Then this is the first value that you are going to get. Alright, so before that, maybe I need to write out one step here. What's the meaning of 0.5 here? So basically it means that I need to substitute 0.5 into my iterative formula. Okay, and now I want to put in my answer here. So my iterative here, my iteration here should be given to 4 decimal places. So you have a look here. The answer for this one, 4 decimal places will be 0.4581, right? So I'll put it as 0.4581. Okay, then now I want to continue the iteration here to alpha number 3. So to get the alpha number 3, we are trying to put this particular alpha 2 into the iterative formula again, then to get the next answer. Then for the calculator part, we press calculate again, repeat the process. So press calculator, calculate again. They're asking what is the value for x that I want to input. So we key in this one, 4581, 0.4581, and we press equal sign. And from here, you can see the second value here. The next value is 0.4795. Okay, so I will just type in or maybe copy in 0.4795. 4795. Okay, then I check for next value, alpha number 4. So maybe you will be asking, when should I stop the iteration? You can stop the iteration when your alpha correct to 2 decimal places are repeated in your iteration. So as an example, for this one, if I want to write my answer into 2 decimal places, it will be 0.46. Then for this one, it will be 0.48. So you can see that 0.46 and 0.48 are not repeated yet, right? So that means you have to continue your iteration. So the next iteration again, repeat the process in the calculator, press calculate, key in the value of x. Now you should key in 0.4795. So 0.4795. Okay, then you press equal sign. And again, please copy in the 4 digits, 4 decimal places number into your solution. So 4685. So the next number will be 0.4685. Okay, so if I double check the answer for 2 decimal places, it is 0.47. Again, not repeated yet. So I continue this process again until I get the answer with 2 decimal places repeated. Okay, so again, calculate 0.4685 equal sign, then 0.4741. Okay, so 0.4741. Check the answer. This is 0.47. Alright, so it seems like the 2 decimal answer number, right, are already repeated. So you can conclude that this is your root. Root equals to 0.47. Okay, and usually for me myself, I prefer to double check again by doing one extra iteration just to double confirm, right? So I will repeat again. So for calculate 0.4741, that equals sign. So 4713, 0.4713. Yeah, I think so this is obvious enough lah. Okay, that up to 2 decimal places, all my answer is 0.47. So this is actually my root or the alpha. So the alpha will be equals to 0.47, correct to 2 decimal places. Okay, yeah, so this is how we solve the question. Right, so question number 8. They want us to express this expression into this particular form where r is greater than 0 and alpha is for the in the first quadrant. So state the exact value of r. So I think we need to aware of this, yeah? Exact value for the r and also for alpha, correct to 3 decimal places. Okay, so first of all, before we can express our answer, our question into this part, right? We have to make sure that we are having the sine x and also cos x here. But if you have a look for this original question, we are having cos x plus pi over 4. That means you have to simplify this part so that we have something with cos x only without the cos x pi plus pi over 4. Okay, so first of all, let us start to expand it and simplify first. So this is the first step. So 3 sine x plus 2 square root 2 cos x plus pi over 4. Okay, this is a compound angle. To expand it, you can use compound angle formula. So I will try to write it out here. For compound angle formula of cos A plus B, right? You can get it from the formula booklet, yeah? I just lazy to go and check, so I will just write it out here directly. So for cos A plus B, it should be cos A plus, cos A cos B, then minus sine A sine B. Okay, so in this question, our x is the A, our pi over 4 is the B. Therefore, if you try to expand it, you will have something like this. Cos A, then cos B, minus sine A and sine B. Alright, then I try to multiply the two sub 2, right, into the both term, and also try to simplify them with all the value for cos pi over 4 and also sine pi over 4. Okay, so this is what I'm going to have now. So 2 sub 2, copy the cos x, cos pi over 4 is sub 2 over 2. Then same thing happen here, I'm having 2 sub 2 sine x, sine pi over 4 is sub 2 over 2 as well. Okay, then simplify the expression. I'm having 2 cos x. Then this one, I'll be having 2 sine x. Then rephrase it again. I will have sine x plus 2 cos x. Yeah, when you express or expand your expression into this form, then only you can try to change it become the pattern here. Alright, we shouldn't have any compound angle before you want to change it become this particular pattern. So you can step after I expand everything. So I will be having sine x and also cos x. Sine x plus 2 cos x. Okay, then now I want to let sine x plus 2 cos x. And we try to find out the r sine x plus alpha. R sine x plus alpha. Okay, so to get the r, the formula for the r is a squared plus b squared. So your 1 here is the a, the b here is a 2. So it will be equals to a squared plus b squared square root. That's why you're having a square root 5. And we want to keep it in the third form, so we just keep it as square root 5. And then for the alpha, it is tangent inverse b over a. So it will be tangent inverse 2 over 1. Okay, so for the value of alpha, right, if you are not so sure whether you want to put it in the angle form, the degree or the radian form, just have a look for the unit here. You can see that the alpha is given from 0 until pi over 2. So pi over 2 is basically radian. Therefore, your final answer should be in the form of radian as well. So please make sure that you press calculator, change your calculator into the radian mode. Then you should write, by right, you should get 1.107. Correct to 3 decimal places. All right. Okay, so this is a particular step for us to find the r and also the alpha. And therefore, if I rewrite my expression again, the original expression is this one. Can be written as sub 5, then sine, and also x plus alpha. This is how we actually get the value for alpha and also the r. All right. Okay, then let's continue further to part number B. All right, so for part number B, they said hence solve this particular equation. Okay, so since they are using the word hence, that means you have to use the result in part A to continue with the solution here. All right, but if I want to compare my answer in part A, right, so I try to write out first. So 3 sine x plus 2 sec 2 cos, then x plus pi over 4. Okay, I try to compare the answer in part A with the B here. Okay, so again, let me copy out the whole equation first for part A. So sub 5, then sine x plus 1.107. Okay, so if I try to compare this and this, right, you will see that I'm having 3 and also 2 sub 2, but here is having 6 and also 4, which means that later I need to factorize out the 2. If I factorize out a 2 from this equation, then I'm having 3 sine theta over 2, then plus 2 sec 2 cos, then pi theta over 2 plus pi over 4. If I factorize out a 2, then I double compare again for the second time, this one and also this one. You will see that the pattern are almost the same. The difference is here. The x become pi theta over 2 in this particular equation. The x become the theta over 2 in this particular equation here. All right, so that means if I want to use this result in this solution, I have to change the x become become theta over 2. Okay, yeah, then after that, we can continue from there and solve for the equation. So let's start first, yeah. I'm having sine 6 sine theta over 2 plus 4. Okay, so first step, I factorize out a 2 from the equation. Alright, so since I'm aware that, this particular pattern inside this big bracket is the same like what we have in the first pattern just now, just that the x has become theta over 2, right? So that means I can substitute my result in first part into this particular expression or this particular part here, but we have to change the x become theta over 2. Okay, and it is equals to, oh sorry, I shouldn't put a 0 here, yeah, I made careless mistake just now, it should be a 3, not 0. Okay, alright, then now for this question, they want us to get the value for data, right? Okay, so we can continue to solve the equation to get the value for the data. So first of all, I try to move all the constant to the right hand side. Okay, so I'm having 3 over 2 sub 5. Okay, and after that I need to solve the equation so that I can get a final answer for the data. But before that, I need to know what is the range of the data that they will accept. So in this question, they are saying that data is between negative 4 pi until positive 4 pi. Alright, so just to make us more convenient later, yeah, I want to know what's the value for negative 4 pi. So the negative 4 pi is actually negative 12 over something. Negative 12 over 5664, let's say. Alright, and then 4 pi, it will be positive 12.564 lah, okay? So that means I want to get this value first so that later it is more convenient for me to decide whether my data is in the range or not. Okay, so that's the first thing. And second thing, later when I want to find out the answer for data, right? Basically, I'm always using the answer. Okay, I will look for the answer according to the quadrant. So for first quadrant, everything is positive. Second quadrant, sine is positive. Third quadrant, cos is positive. Third quadrant tangent is positive. Third quadrant tangent is positive. Then fourth quadrant cos is positive. I think all of us know about this. And for this question, because they are having the negative angle and also the positive angle, so we have to consider the answer from two different directions. Okay, so if I am looking for the positive angle, that means it is in anti-clockwise direction. The answer in the first quadrant is the basic angle. The theta here, I put the sign here as a basic angle, yeah. Then for the second quadrant, to get the answer, I have to take pi minus the basic angle. For the third quadrant, I will take pi plus basic angle. And the last quadrant will be 2 pi minus basic angle. But if I'm going to find out the answer in a negative value, which means it's in the opposite direction. Opposite direction here means that clockwise direction. Then you have to start from the fourth quadrant. So for the fourth quadrant, to get the answer, we need to put a negative in front of a basic angle. Then for this particular quadrant, it will be negative pi minus basic angle, negative pi plus basic angle, and also negative 2 pi minus basic angle. Alright, okay, so after I'm done with everything detailed here, then I can start to find out the solution. Alright, so let's start. So first of all, I want to get the basic angle, which is the theta in my diagram here. Alright, so I want to find out the basic angle. This basic angle is the theta in the diagram. It is actually equal to sine inverse 3 over 2 sub 5. Okay, so if I try to press calculator, that helps me. I will be getting 0.735. Okay, I should get 0.735. Okay, and now let us have a try to find out the answer. Okay, so to find out the answer, right, you should know that it is theta, because I take the sine over becomes sine inverse. So the bracket I left in the sine is this one. So the answer that I'm currently getting is theta over 2 plus 1.107. Alright, so at this stage, I need to go through the quadrant and accept the answer that I want. Okay, so let's have a look for our equation. I'm having sine positive. So sine positive means that I want to accept all the quadrant where the sine is positive. So I start with the blue color angle first, which is the positive angle. That means I will measure it in anti-clockwise direction first. So for the first quadrant, is it sine positive? Yes, right? So I want to get the answer from this part. So the answer is theta. So theta means the basic angle, which is 0.735. Okay? All right. And after that, we go to the second quadrant. In this second quadrant, is it sine positive still? I'm looking for sine positive again. So is in this quadrant, is it sine positive? Yes. So to get an answer from this quadrant, you have to take pi minus theta. So if you take pi minus theta, by right you should have 2.406. So you take pi minus the basic angle that we get just now, 0.735. So you get 2.406. Okay, if you press calculator, right, you might get 2.407 or maybe 2.405. But just to remind you, if I want to get the most accurate answer, right? Okay, I want to get the most accurate answer. When I take pi minus the basic angle that I'm using is the long value for this one. This one I already cut it short for me to write out my answer conveniently lah. Okay, so I cut it short. But when you are doing any calculation in your step, right, this basic angle, you have to try to keep it longer. So that means if as long as possible, that will be the best. All right, so that you can get the most accurate answer until the end lah. All right. Okay, so this is what I have after I go through with this one. Okay, then the next one. Third quadrant, sign is not positive, so I don't want to answer from here. Fourth quadrant, the sign is also not positive, so I don't want to answer from here. Okay, all right, and after that, I'm going to the other way around. That means I want to go for negative angle. So negative angle, I will start from the fourth quadrant. So first of all, I ask myself, do I have sign positive in this quadrant? No, so I don't want to answer from here. Do I have sign positive in this quadrant? I also don't have, so I don't want to answer from this part as well. Then for this answer, do I have sign positive in this quadrant? Yes, right? So to get this answer, I will take pi plus the basic angle and put a negative sign in front. So if I try to use pi plus 0.735, basically you will get a negative 3.877. Okay, so again, all these answers I have cut it short already. So when you do the calculation, the 0.735, please make sure you use the original value, the long one. As long as possible, then it will be the best. Okay, then we go to this last quadrant here. All right, so for this particular quadrant, you can see that, oh, sign is also positive. So I want the answer from this part. So to get the answer from this part, it is 2 pi minus the basic angle. So if you try to simplify using calculator, this is what you have. You have negative 5.548. All right, so I have go through the positive angle once, and I also go through the negative angle once. All right, so for one round, one round. Okay, one round means one cycle, 0 until 2 pi, right? So negative also I go from 0 until 2 pi. All right, so some students will ask, how I know that I actually have to stop after I go positive angle for 2 pi for one round, and also I go negative angle for 2 pi, which is one round. All right, if you are not so sure, of course you can continue more quadrants. All right, then for me, I know that I have to stop at one cycle or one round. Sorry, one round means 0 until 2 pi. It is because of in the range that I'm having here, they did mention that the theta is from negative 4 pi until 4 pi. But in my equation, I'm having theta over 2, right? So that means if I consider for theta over 2, it will be around, roughly, okay, roughly from negative 2 pi until positive 2 pi, which is one round. Okay, but of course, maybe during the calculation, there will be some answer out of the range. We just need to adjust it back. But in general, I know that for theta over 2, the main idea that we need to find out the quadrant, right? Find out the answer from the quadrant is go for positive 2 pi and also go until negative 2 pi, which is one round each direction. All right, so therefore, when I go through one round each direction, the theta over 2 answer that I get would be something like this. Okay, all right, then now, next step. So for the next step, what I need to do is I want to get the theta over 2. Okay, so let us have a look here. So I want to get the value for theta over 2. So to get the theta over 2, right, what are we going to do is we take 0.735 minus 1.107. That's the first answer. Then 2.406 minus 1.107. Second answer. The third one is negative 3.877 minus 1.107. And lastly, we want to have negative 5.548 minus 1.107. Okay, so this should be the full answer that I get after I bring the 1.107 over. All right, and next I want to get the data. Okay, so to get the data, I need to take the answer here, multiply with 2, right? Okay, so for this step, we need to double check and see whether our data is in the range or not. Okay, so let's have a try for the first answer here. 0.735 minus 1.107 and then times 2. So if you times 2, yeah, wait, yeah, let me have a look. Okay, so let's try again. 0.735 minus 1.107. Okay, so I take the answer times 2. So I'm getting this answer negative 0.744. Okay, then for the second answer, 2.406 minus 1.107, then times 2. The answer that I get is 2.598. Okay, then for the third answer, negative 3.877 minus negative 3.877 minus 1.107. So I get this value times 2, negative 9.968. And lastly, negative 5.548 minus 1.107, then times 2. So the answer that I get is negative 13.31. Yeah. Okay. All right. So now, if we try to observe these few answers here, right? Okay. We double check with the range, yeah. Okay, so again, for these two answer, the first two answer should be a positive angle. But after I minus 1.107 and multiply with 2, one of the answer become negative. So that means this value is not something that I should expect because we should try to get a positive angle because these two angle are from positive angle. There will be two answer from positive angle, two answer from negative angle. So this answer, after we do the calculation, we realize that if from positive, it has been changed to negative, which is the answer that I don't want. I want to make sure it is still positive. Okay, so I need to do a little bit of adjustment here. And then for these two negative angle, if you try to observe, right, you realize that, oh, this value has already out of the range. Because if you have a look for the range here, our negative value should be until negative 12.5664. Okay, all right, so these two answers need to do some adjustment before we can accept it. All right, so again, yeah, this value is not accepted because it by right it should be a positive angle, not a negative. Therefore, when we do any calculation after we get the data, it become negative, which is something that we don't accept. We want to have the positive value. Then for this one, okay, although it is still negative value, but it's already out of the range. So for these two values, we have to do a little bit of adjustment before we can continue for the calculation. So how are we going to do the adjustment? So we have to go back to our previous step here. Okay, go back to the previous step because this value is too small. So for this particular value, if I want to adjust it back, become a positive value, I need to add 2 by. That means instead of getting this answer, I need to get the answer 1 round later. Okay, 1 round later. All right. Then for this answer is also the same. Because this value is too small, which is out of the range already. So to adjust it back inside the range, I also need to get the answer 1 round later. So which is plus 2 pi as well. Okay, all right. So if you try to put it plus 2 pi. Then now we recalculate this particular answer and also this particular answer again. Right, so 0.735 minus 1.107 plus 2 pi. Okay, after that you multiply with 2. So from here, you'll get 11.696. Then for the last part here, you're having negative 5.548 minus 1.107, then plus 2 pi. After that, you need to multiply it with 2. So you're having negative 0.744, something like that. Okay, all right. So if you double check your answer now, everything looks like go back to the normal. That means your theta should be having 2 positive value, which is in the range, and also 2 negative value, which is also in the range. All right, so simplify our final answer in one single step here. I want to correct my final answer to 3 significant figure, yeah. So I try to write out the smallest value first. So I'm having negative 9.97. Then negative 0.743. Okay, so when pressing calculator, I'm using the short value now. So this one, you should keep everything as long as possible. So by right, it should be 0.743. Then this value, correct to 3 significant figures, should be 2.60. And this last value here will be 11.8 if you're using the original value in your calculation. So for me, I didn't use the original value because I write everything short. Okay, but of course, when you are trying out the question, please make sure that you press the calculator value as long as possible, right? So by right, after the adjustment and everything, this is the correct full answer for the data. Alright, so I believe that this question, to get the data, there are many other ways that you can get all the 4 correct value for the data, but the method I'm using here is go back to the basic, where you need to go through the quadrant slowly and try to understand which answer from which quadrant we should accept it. Alright, yeah, so this is how we solve question number. Question number 9. Relative to the origin O, the position vector for A, B, C, D are given like this. So I'm having the vector OA, OB, and OC. They want us to show that OABC is a rectangle. Right, so to show quadrilateral is a rectangle, there are a few important points that we need to show. Okay, so first of all, it is very important that we must show one of the angle here, any of the angle here are perpendicular to each other. Okay, because for a rectangle, they should be perpendicular, right? If let's say they are not perpendicular, then it means they are parallelogram. But since they are asking us to prove something that's more strict, which is a rectangle, therefore the perpendicular must be included in your proving. Okay, so perpendicular must be included in your proving. So for me here, what am I going to do is I will try to prove that all the length here, the length for the opposite side are equal to each other. This one also equal to each other. Then also proving that the angle between each side here will be a 90 degree. Then from here, I think we can show that it is a rectangle. All right. So some students prefer to prove that, oh, they are having a rectangle and also the same diagonal, the midpoint also can. It depends on how you want to prove it. But for me, I will use these two property to prove. So the length are equal for the opposite side and also the perpendicular, the angle between the two sides here are perpendicular to each other. Okay, all right. So what am I going to do now is I will try to just label, simply label. All right, let's say I'm having 0, A, B, C in this way. So easier for me to do my calculation. All right, I know that my OA is 5, negative 2, and also 1. I try to find out the CB first. So the vector from C to B. So from C to B, I'm having 3, 4, negative 7. And then CO. Oh, sorry. I want to have CO plus OB, right? So CO, I should have negative 3, negative 4, and also positive 7. CO plus OB. So OB is 8, 2, and negative 6. Okay, so if I try to simplify, I'm having a 5, then negative 2, and also a 1, which is actually equals to OA. All right, so from here, Okay, I can say that OA is parallel with OB. Oh, sorry, OA is parallel with OB. With CB. And at the same time also, since they're having the same vector, right? That means the modulus, the length for OA is equals to the length of CB. I no need to purposely go and find the length. It is because of when I'm having the same vector from OA to CB, right? It is not the, it is not the multiple of the other one. It is actually exactly the same vector. So the length is the same as well. So from here, I can also conclude that the modulus of OA equals to modulus of CB, which also means that the length of OA equals to the length of CB, right? Okay, so that's the first one. So I want to prove the other side. So to prove the other side, right? Just now I use OA ma, so I want to compare now OC with AB. Alright, so I try to find AB now. So to find the AB here, I'm having AO plus OB. AO is -5, 2, and -1. Then plus OB. OB is 8, 2, -6 again. So if I try to simplify this answer, I'm having 3, then 4, and -7. And again, if you try to observe this, it is equals to OC. That means AB and OC are parallel to each other. Which also means that since they are having the same vector, right? So if you try to find out the length for AB and also you find out the length for OC, they are the same. So here I have successfully proved that the length of OA equals to CB and also the length of OC equals to AB. Alright, then now what I want to do next is I want to prove the perpendicular property in the rectangle. Alright, so to prove the perpendicular, you can use any side that you like. Okay, so you can use either OC and CB or maybe AB and CB or whatever. Alright, so for me here, I'm trying to use OC and OA. I want to prove this one, OC and OA. If I want to prove this particular angle is 90 degree, then what am I going to do is I want to find out the dot product between OC and also OA. So OC dot OA, I want to see what do I get. If I get a 0 for this dot product, then basically it means that they are perpendicular to each other. Alright, if you get a 0 lah. Alright, so I'm having 3, 4, -7, 5, -2, and also a 1. So 15 minus 8 minus 7, so I get a 0. So what does this mean? It means that OC is actually perpendicular to OA. Right? And since we already know that the other angle, okay, are parallel to each other, since we know that OC is parallel with AB, like what we proved just now, right? And also OA is also parallel with CB. Okay, so this also implies that all the other angle will be 90 degrees to each other. So you need to prove all the 4 degree here, the 4 angle here are 90 degree. You only need to prove one, and then by using the result that all the sides are parallel, all the opposite sides are parallel, right? Therefore, all the other angle are perpendicular also. Are perpendicular. Okay, which means that you are also having maybe CO intersect is perpendicular to CB. Okay, then BC is perpendicular to BA, all the angle lah, and also AB is perpendicular to AO. Okay, so this is the two main things that you need to prove, and therefore the OABC and the quadrilateral OABC is actually a rectangle. All right, so again, what I want to emphasize here will be, if you want to prove that this particular shape is rectangle, the perpendicular, the angle, the 90 degree among between the line, between the sides, should be included in your proving. All right, so either you can find out the length that each side are the same, or some students, they might want to use the diagonal, is the same point also can. All right, but the 90 degree here is something that we have to include, all right, in the solution here. All right, yeah, so this is how we solve part A. Let's continue to part number B. Use a scalar product to find the acute angle, highlight the keyword acute, between the diagonal of OABC. All right, so like what I draw just now, they said the acute angle between the diagonal OABC. So let's say this is OABC. If I want to find out the angle, okay, so assume that I'm not sure now which side is longer. Like maybe OA is longer or maybe OA is shorter than AB. Okay, so I also don't know which angle in the diagonal is acute angle. Let's say I don't know. But I know that if I want to get the angle between any two vectors, right? What am I going to do is like, I need to make sure that the vector I'm using are both going out from the same point. As an example, if let's say I want to get this data. If I want to get this data, right, the vector that I'm using must be going out from the point here, going out. So that means I should use the vector CA and also the vector OB to get the angle for theta. Okay, so this is something that you must know. All right, you cannot tell me that I want to find out CA, AC, and then BO. Cannot. So both of them must be going out from the same point to form the angle. So if let's say I want to find this particular data here, the vector that I should use would be CA and OB. Okay, all right. So now I try to use CA and OB here. Okay, so CA dot OB. I think we have got all the CA just now from the calculation in the earlier part, if I'm not mistaken, right? CA. Oh, I don't have CA here. Okay, never mind. CA and AC are the same, right? Did I use any AC? Also don't have. Okay, so never mind. We try to find out the CA first, yeah? Okay, so before I start, let's find out the CA first because I don't have the CA. All right. Okay, so what is the CA here? Basically, CA means CO plus OA. What is my CO? CO is -3, -4, and also 7. And what is the OA? All right, so OA is 5, -2, and also 1. So this is how we find the CA. So if I try to find the CA, I will have 2, then -6, and also 8. Then now only I start using the dot product, yeah? So CA dot OB. OB I have already, right? So you can directly get the answer from the first part just now. CA dot OB equals to modulus CA multiply with the modulus of OB, then cos theta. Okay? All right, so what is CA? CA is 2, -6, and also the 8. What is OB? So OB is 8, 2, and -6. Okay, then I want to find out the square root, the modulus of CA and OB. So 2 square plus -6 square plus 8 square. Same thing happened for the OB. It is 8 square plus 2 square plus -6 square. Then cos theta. Okay, so for the dot product, I take x multiply with x, y multiply with y, z multiply with z. So I'm having 16 minus 12, then minus 48 equals to square root 104 for this part. This one, the second one also the same, square root 104 cos theta. So I'm having cos theta equals to -44 divided by 104. Okay, because of this question, they want us to find out the acute angle. So acute angle means it is in the first quadrant. So in the first quadrant means that our cost value must be a positive value lah. Then from here, I'm getting a negative value, right? Negative value will give us the obtuse angle, but I want acute angle. So to get the acute angle, basically I can just directly make it become positive. So I'm having cos inverse positive 44 over 104. Okay, so please press calculator and see what angle do you get. So you should be having 1.13 lah in the radian form, or if you want to make it become degree, it should be 65 degree. Okay, yeah, so this is basically how we get the acute angle between the diagonal. All right, so this is how we solve question number 9. So we are now at question number 10. We are given a function like this, a rational function, and that a is a positive constant. They want us to express a function here in partial fraction. Okay, so to express this function into the partial fraction, first of all, let's have a look whether is it a proper fraction or improper fraction. Okay, so we are having the x. Okay, when I multiply all the x here, I will be having x power 3. And on top, it is just a constant. All right, so that means on top, I'm having the degree equals to 0. At the bottom, I'm having degree equals to 3. So very obvious, you can see that the degree on the top is smaller than the degree at the bottom. Therefore, I'm having this as a proper fraction. So when I want to find out the when I want to find out the partial fraction from the proper fraction, I can directly split them into the partial fraction pattern that I want. Okay, so I'm having 36a squared divided by, okay, so 2a plus x, 2a minus x, and also 5a minus 2x. Okay, I can split them, become 3 fraction here, a over 2a plus x, then b over 2a minus x, and the third one will be c over 5a minus 2x. Okay, so multiply the whole equation here by using the original denominator. If you multiply every single term or every equation here, the whole equation here by using the original denominator, so by right you will be having 36a squared. Therefore, the a here you will be having 2a minus x and also 5a minus x, minus 2x. Okay, then the second one will be 2a plus x and 5a minus 2x. Then the third one, 2a plus x and then 2a minus x. Okay, so this is what we have for after you multiply the whole equation by using the denominator of the original function. All right, and after that, we want to get rid of some factor here so that we can find out the a, b, and c. All right, so first of all, we try to look at this particular bracket, 2a minus x. Okay, so this is what we have for 2a minus x here. So for these two factor, right, if I try to let x equals to 2a, then this particular bracket will become 0. Okay, because if I substitute x equals to 2a here, then I will be having the whole bracket 0, 2a minus 2a is 0, right? Okay, so now substitute x equals to 2a into this whole equation here, I will be having 36a squared equals to, this bracket is a 0, therefore the whole term here becomes 0. This is also a 0, the whole term in C also 0, so we have only something in part B. So what do I have for the B here? Okay, so 2a plus 2a, I have 4a. Okay, then 5a minus 4a, you are having the a, right? Right, so if you try to simplify this particular equation here, you'll be having 4a squared b. And very easily, you can get the value of the b. So b should be equals to 9. Then now I'm going to aim for the second bracket so that I can get some other constant. So maybe now I want to focus on this one, 2a plus x. So I'm having 2a plus x here as well. So for these two brackets here, if I want to make these two brackets become 0, I will need to let x equals to negative 2a. If you put x equals to negative 2a here, this particular bracket becomes 0, so the whole term in b becomes 0. The whole term in c also becomes 0, which means that you can get the value for a. Right, so let's substitute it again. Okay, so x equals to negative 2a, right? 2a minus negative 2a, you're having 4. So I'm having a multiplied with 4a. And 5 minus negative 2a, 5a minus negative 2a, what do I have? So by right, you should be having 9a. Okay, all right. So you'll be having 36a squared plus a with 36 as a squared. So your a should be equals to 1. All right, then the last term. So to get the last term, I need to look at the final bracket that I never used before, which is 5a minus 2x. So for 5a minus 2x, if I want to let this bracket become 0, I need to put x equals to 5 over 2. 5 over 2a. Okay, so if I substitute x equals to 5 over 2a in the whole equation, these two purple color bracket will become 0 definitely. So what do I have here in the term of c? So if you try to simplify this particular term, you'll be having negative 9 over 4a squared with the c. Alright, and simplify it further, your c would equals to negative 16. Okay, and since you already successfully get all the value for a, b, and c, so we can write out our partial fraction again. I'm having 36a squared, then divided by this 3 bracket here, which is 2a plus x, 2a minus x, and also 5a minus 2x. And the partial fraction that we get is actually 1 over 2a plus x. Okay, then plus 9 over 2a minus x. And also minus a 16, negative also minus 16. Then 5a minus 2x. So this is basically how we get the partial fraction for this particular function. Okay, so let's proceed to the next part, part number B. Okay, so for part number B, they want us to find the exact value. Can you please highlight the keyword exact? This actually tells us that your final answer cannot be in any decimal number, alright, exact value for this integration. And also our final answer must be in this pattern, P ln Q plus R ln S. And they did mention clearly also that all the P, Q, R, S are, P and R are integers, Q and S are prime numbers. So they have stated the pattern of the final answer clearly. So that means after the integration later, you need to rephrase it so that you can get the particular pattern that they request in the question. So let's start first. Okay, they want us to integrate negative a to positive a for the function fx. Okay, so we can't integrate the big rational function directly, but we can actually integrate their partial fraction. Because the partial fraction that we get just now, right, it is a smaller term, and also it's easier for us to observe and see which method are we going to use to integrate them. Okay, so I just copy out and substitute my result in first part into this integration here. Okay, so I think the integration for all these terms should be quite simple because you are having all the denominator with a bracket with power 1, x power 1, and also the whole bracket is a power 1. If I want to integrate them, okay, so 1 is a constant, no need to do anything, right? So when I integrate ln, when I integrate 1 over 2a plus x, by right, I should be having ln 2a plus x divided by 1. Because the coefficient of x is a 1, right? So should be divided by 1. Okay, then after that, for the second term here, it is a 9. 9 is a constant, so I just keep it in front. Then integrate 1 over 2a minus x, I will be having ln 2a minus x. And divided it by negative 1. how to get this particular -1 here? You have to differentiate the thing inside the bracket. 2a minus x, you are getting a -1 after you differentiate it, right? So you have to divide it by -1 in integration. But for differentiation, maybe when you are doing all the process in the reverse direction, then basically you need to multiply your answer with -1. But integration means divide lah. Differentiation usually is a multiply. Okay. All right. Then again, -16. 16 is a constant. I just try to copy it. Integrate 1 over 5a minus 2x. I will be having ln 5a minus 2x, and I need to divide my term here by -2, because when I try to differentiate 5a minus 2x, I will get -2. Alright, so after I complete the integration, I should substitute in my value, the limit, upper and lower limit. Okay, so for my own practice, usually I prefer to simplify all my term here first before I can simplify them, or substitute in the limit. Okay, so I prefer to write out in the proper way. So for this one, I'm having -9 ln 2a minus x. Then for this particular term, I'm having 8, okay, ln 5a minus x. That only I substitute in the value for -a and also +a. Okay, so first of all, let us substitute the a first. So if I substitute my a into the first term, I'm having 2a plus a, then I got 3a, ln 3a. Then for this second term here, if I substitute the a inside, I will be having ln a. Okay, -9 ln a. And then if I substitute the a in the third term, I will be having 8. Then ln 5a minus 2a, I get 3a here. Okay, all right. Then after that, I want to substitute the second a, the second value, which is the lower limit, -a. If I substitute -a here, I will be having ln a. 2a minus a is ln a, right? Then -9. Then ln 2a plus a is 3a. Then plus 8, 5 plus 2 is 7. So you try to just simplify the term very carefully without doing any careless mistake before you simplify your answer into the pattern that they want. Alright, and now I try to further simplify my answer to get the pattern that they want. Okay, I will group this ln 3a and also 8 ln 3a. Ln 3 is like an apple, so you're having 1 apple plus 8 apple. So eventually you're having 9 apples in total. Okay, then minus 9 ln a. Okay, so for the term at the back, I try to multiply in the negative first. So I'm having negative ln a plus 9 ln 3a minus 8 ln 7a. Yeah, all right, then next one. Slowly simplify it one more time. What do I have here is I'll be having, okay, so this one, 9 ln 3a plus 9 ln 3a. So what do I have? 9 plus 9 will get 18, right? So I will further simplify, become 18 ln 3a. Okay, and what will happen next? So the next one will be this one, negative 9 ln a minus ln a. So this is like negative 9 orange minus 1 orange. So you're having negative 10 orange. Okay, then after that, we're having negative 8 ln 7a. Yeah, all right. So we look at all this term now, right? It looks like it's very hard for us to express into the pattern that they want. Okay, so don't worry, we try to slowly expand it again. All right, so now for the ln 3a, right? It can be written as ln 3 plus ln a, because when you're having ln a plus ln b, you can combine them, become ln a times b. So we are going to do it backward. Okay, so for this ln 3a here, I'm trying to separate, become ln 3 plus ln a. Simply happen for the ln 7a, I'm going to split it, become ln 7 plus ln a. Okay, so this is what I plan to do for the next step. So I'm having 18 ln 3, then plus 18 ln A. Because ln 3A can be written as ln 3 plus ln A, so 18 need to need to multiply into both terms here. So this is what I get here. Yeah. Then for negative 10 ln A, I don't do anything yet. I cannot further factorize it or expand it or whatsoever, so I just keep it like this. Then for the negative 8 ln 7A, I will be having negative 8 ln 7, then minus 8 ln A. Okay? Alright, so next one. From here, you can see that we are having 18 ln A minus 10, which is 8 ln A. 8 ln A minus 8 ln A, you will be having 0. So from here, we already get rid of the term with the A. And now what left with us is this one, 18 ln 3 minus 8 ln 7. Okay, and it seems like I can't further simplify anymore, right? And let's check and see whether is this pattern is the pattern that requested by the question. So we are having P ln Q plus R ln S, which is true, correct? And then P and R are integers. So the number in front are integers. So 8 and also negative 8 are integers, no problem. And also QS are prime number. Q and S inside the ln are prime number. 3 and 7 are both prime numbers. So this is basically the correct answer that they want. The correct answer pattern that they want, right? Okay, so maybe I will put a small note here. From this step to this step, basically we are using the idea of ln AB can be written as ln A plus ln B. Okay, right. So this is how we solve question number 10. Okay, so we are at the very last question for this paper, question 11. They are giving us with the variable y and also the data, right, in this differential equation. Then they give us also the initial value set or initial boundary value for this particular differential equation. They want us to solve it and find the exact value of tangent theta when y equals to 1. Okay, so let's start with the first part first. They want us to solve the differential equation. So first of all, for any differential equation given, right, we try to separate the variable to two different sides. Okay, so before we can get the general or particular solution. Okay, so this is my differential equation that I have here. Okay, so let's start. So I'm having 1 plus y, then 1 plus 2 cos 2 theta, dy dx equals to e power 3y. Okay, I want to keep my dy here. So that means I'm trying to move all my terms with the y over left-hand side. So I will be having 1 plus y divided by e power 3y. I bring the dx over and it will become dx on the left, on the right. So, sorry, I think I copied the wrong variable, right? It should be theta. Okay, so I want to keep my theta on the right-hand side. And this 1 plus cos 2 theta, I will bring it over, become 1 over 1 plus cos 2 theta. Okay, and after that, I start the integration. Alright, then from here, basically we need to think about the method or technique that we want to use for the integration here. Okay, let's have a look for the left-hand side. For the left-hand side here, originally it looks like a fraction, but if I try to bring up the e power 3y, it will become e power negative 3y. Okay, so if you have a look for this particular expression, basically it consists of two functions, the product of two functions. The first function is 1 plus y, the second function is e negative 3y. So this is a product of two different functions, right? So by right, the technique of using this will be, for this part, basically should be the integration by part. Okay, so later we are going to apply integration by part on the left, for the integration on the left. And let's have a look for the expression on the right. How can we actually try to simplify this particular term? Okay, so you can see that for this fraction, it involves 3 rows. And very obvious, it does not belong to the f prime x over fx pattern, right? It does not belong to this pattern because you must have something on top if you want to make it become f prime x over fx. Therefore, we exclude this particular technique here. And for the trigo, basically it will be easier if I have a simple denominator, that means without the addition one. If let's say I'm having 1 over a simple denominator, then it might be easier for us to integrate it. So I will try to think about 1 plus cos 2 theta. What are the identity that I can use to make my integration easier? Alright, so let's go through with all this. When I'm having cos 2 theta, it is a double angle. You can try to consider I'm having 2 cos square theta minus 1. I'll be having 1 minus 2 sine square theta, and also cos square minus sine square. Okay, so for the cos 2 theta here, if I substitute by using 2 cos square theta minus 1, the 1 and also the negative 1 will balance up. That means it will be cancelled. Then I left only 2 cos square theta at the denominator, which means that it becomes much more easier compared with addition at the denominator. Okay, alright. So now for the right hand side, I will be replacing the cos 2 theta by using 1 plus 2 cos square theta minus 1. Then d theta. Okay, so maybe from here, I will want to show the hint here by using cos 2 theta equals to 2 cos square theta minus 1. Okay, so this part will be using integration by part later. Okay, so I will solve the part left hand side later. Okay, then now I look at the right hand side again. If I continue to simplify my answer here, I'm having 2 cos square theta. And after that, 1 over 2 is a constant, right? So 1 over cos, I will be having secant squared. And when you want to integrate secant square, basically it is a basic integration in the trigo. So we learn 3 types of basic integration, right? Sine, cos, and also secant square. So integrate secant square, you get tangent. So our right hand side has solved. Okay, we have solved our right hand side here. And now let's continue to the left hand side. Okay, so for the left hand side, I'm going to use the integration by part. Okay, so I want to apply integration by part here. Okay, then now let us have a look for our term here. The 1 plus y is algebra, which is the A. E power negative 3y is actually the exponential, right? Okay, so this is exponential E. Okay, so algebra, we are using the rule LIATE. The higher group will be the U, the lower group will be the dV, sorry. So you can see that A is a higher group, right? Okay, therefore, we are going to let U equals to the group A, which is U equals to 1 plus Y. Okay, then the remaining term will be equals to integration of dV. So integration of dV means integration of 1 dV equals to integration of E negative 3y then dy. Alright, so for those who are not so sure how to decide all this, you can go back to the lecture video that we provided earlier. Okay, and let's have a look for some detail inside. Okay, it will be the, I think, the second last video, okay, in the integration chapter. Right, then after you decide which one is the U and which one is dV already, then we can start the integration by parts slowly. So for the U, I need to find out the differentiation. So du dy equals to 1 and your du is equals to dy. Okay, then for this one, the V, you're having V equals to integrate E negative 3y, you have E negative 3y, then divided by negative 3. Alright, then what is the integration by part formula? So integration by part formula is when I want to integrate u dv, so you can see that the u dv basically is my question. Okay, so what's the u here? The u here is 1 plus y, dv is this whole thing. Okay, so u dv. So what's the u dv do we have here? So we are using the formula integration of u dv equals to uv minus integrate of v du. Alright, yeah, so again, basically this is my question and this is the result that I want to substitute in. Okay, alright, so my left hand side, I want to start with uv minus integrate of v du. So what is my uv? U is 1 plus y, so I put 1 plus y here. What is the v? V is this one, right? So I'll be having e power negative 3y divided by negative 3 minus v du. So v and du, what's the du here? Du here is actually the dy. Okay, then I continue with my value, my term on the right hand side. It will be actually half. Integrate secant square, I'll be having tangent theta. Then plus c. So right hand side is right hand side, yeah? So this answer, left hand side is basically from this integration by part formula. Okay, then now I want to continue further to simplify my answer on the left hand side. Okay, so I will be having negative 1 over 3 with 1 plus y power e negative 3y. Take out the constant, become positive 1 over 3. Integrate e power negative 3y. So you're having e power negative 3y divided by negative 3. Then equals to half tangent theta plus c. Okay? Alright, then again, simplify one more time. We're having negative 1 over 9. Then e power negative 3y equals to half tangent theta plus c. Okay, so this is the general solution that we have for this particular question. And we need to get the value for the c here. Okay, so it is given the initial value or some value, useful value. When y equals to 0, theta is pi over 4. Okay, so I want to substitute these two values inside my general solution so that I can get the value for c. Okay, when I substitute y equals to 0, right, I'll be having negative 1 over 3 minus 1 over 9. Right hand side, I'll be having tangent pi over 4. So tangent pi over 4 is a 1, so half plus c. So from here, you'll get the c equals to negative 17 over 18. Alright? Okay, so after we get the value of c, right, so we already get our particular solution. Alright, so I rewrite it again, yeah. Therefore, our particular solution will look something like this, which is negative 1 over 3, and then 1 plus y, e power negative 3y, minus 1 over 9, e power negative 3y equals to half tangent theta plus c. So the value of c should be negative 17 over 18. Okay, but this is not the end of the question yet, because for this question, they basically ask us to find out the value of the tangent theta when y equals to 1. So let us continue further to solve this question. So when y is equals to 1, what will happen to my tangent theta? Okay, so again, substitute all the value inside. So I'm having a 2, then e power negative 3. This one also e power negative 3. Okay, then try to simplify the term here. So I'm having 2. Negative 2 over 3 e power negative 3. Then negative 1 over 9 e power 3. Sorry, after I bring it down, become the numerator, denominator, it should be having positive power, so e power 3. So negative 1 over 9 e power 3 as well. That equals to half tangent theta minus 17 over 18. Okay, so for this question, they want us to express our answer in the exact form. So I keep my tangent theta first. Okay, then maybe I keep my half tangent theta first. Okay, so I move all the number to the other side. Therefore, when I try to simplify this, yeah, I'll be having 17 over 8, bring it over, become positive, right? So 17 over 8 positive. Then minus, okay, so for these two terms, right? For these two terms, basically you're having negative 2 over 3 and apple, okay, minus 1 over 9 apple, something like that. All right, so what you can do now is you can try to simplify the term here, negative 2 over 3 minus 1 over 9. So you'll be having negative 7 over 9. So I'll be having 7 over 9 with 1 over e power 3. Okay, then bring up the tangent. That means multiply the 2 for every single term here. So 17 over 9. Okay, then minus 14 over 9. Okay, then 1 over e power 3. And if you want your answer looks nicer, you can try to factorize out the 9, 1 over 9. Okay, then I'll be having 17 minus 14, then e power negative 3. Alright, so this is basically how we solve the question 11. Alright, and for this particular part, the more challenging part will be this one, the correct technique using, you should know to decide how to decide to get the correct technique of integration here. Okay, you have to think about all the technique that we have learned in our syllabus. All right, and after that, this is how we get the answer. All right, yeah, so we have finished discussing this paper, and thank you very much for watching the video.